Hello everybody. What we have here is quite an interesting device. It's not typical electrician's test gun, I guess you'd say, but it's something that I think will become increasingly common for reasons I will get into in a second. This device here is a BT, let me just check, it is a gas detector number, or indicator gas number 5, sorry, IG number 5. I have the instructions here. It is basically a gas detection unit. This one here is very good condition. She's a demonstration unit, last calibrated in 1998, and it would appear untouched since then. The rubber is slightly perished, but other than that it's still perfectly functional. If we turn it over here, if the autofocus will, there we go, you will see on the screen we have percentage explosive, so this machine will basically detect explosive gases in the air. On this side we have a very long hose with a nozzle on the end. You get a big long metal tube that attaches to the end of this as well for sticking into manholes. I'll explain why they would have used this. It also has here this cartridge, which is a filter paper, basically to stop crap getting sucked inside the machine. There is another cartridge that goes here, which is to absorb liquids, so petrochemical vapours like petrol, diesel, kerosene, that kind of thing, because again that can damage the sensor inside this unit. On the other side there is a aspirator bulb which connects in here. You squeeze that and it sucks the air in through the nozzle here, through the tube, into the detection chamber inside the machine, and it comes out the other side. This machine outputs the lower explosive level, LEL, which is a number between 0 and 100. What that basically means is how explosive the air is. So a number of 100% means the air will explode if an ignition source is provided. A number of 0% means there is no explosive gas, and any number between 0 and 100 is not explosive, but explosive gas is present. As you can probably guess from the display here, if you have anything over 10-ish%, that's considered problematic, even though it's not actually dangerous yet. That's just an abundance of caution. Before I demonstrate how this works, I think I will explain why I bought this, because it's quite interesting. So 1 second while I go and grab some documents, because this is going to take a bit of explaining. Me buying this device came about through a discussion I was having with a Scottish Gas Networks engineer whom I met while I was out and about, regarding this document here, Developing Britain's Hydrogen Network Plan. As you can see in the 2025-2030 block, which is where we are now, if we go down here to Customer Focused, you can see we are in the middle of this block here. First, 20% blending into gas grid. What that means is that in certain specific areas of the country, they are beginning to roll out a blended gas, which is a mixture of, if I have understood correctly, mostly methane, which is from like landfills and bioreactors and stuff, mixed with maybe some butane and or propane, not clear on that, and obviously hydrogen. And some of you will be aware, some of you will not. Hydrogen is an absolute bastard of a gas to work with because the molecules are tiny. They're absolutely tiny. So it will piss out of any hole that it can get access to. Making a hydrogen-tight anything is basically impossible. You pretty much can't do it. Especially on a gas network which is not designed to contain hydrogen. The gas network in my area was designed for coal gas, which contains tar in it, so it basically would plug holes itself because the tar would cover the hole. When they moved from coal gas to natural gas, it started leaking all over the place and they patched all those holes up, and that's fine now. Now they're transitioning from natural gas to hydrogen. Again, it's going to start pissing out everywhere. And when gas leaks, especially underground, but anywhere, when gas leaks, it will diffuse into the nearest airspace. So underground, that is usually into one of our cable ducts. So your cable duct will end up filling up with whatever gas is leaked. In this case, hydrogen. Normally, that's not so much of an issue because with natural gas, when that leaks, the odour compound that they add into it to make it smell of gas also will leak with it. When it's underground, that can sometimes get filtered out by certain soil types, but that's not really an issue here. The soil here is very sandy, so it doesn't filter much. It just sort of diffuses through straight away, and you can usually immediately smell gas when there is a leak. With hydrogen, that doesn't happen, because the hydrogen molecules themselves are much, much smaller than natural gases, and much smaller than the odour molecule. So you can have a quite serious hydrogen leak, expelling a very large amount of hydrogen into your duct chamber, and you won't be able to smell anything. So you really need a detector in order to detect the gas, which is why I bought that, because hydrogen, very, very explosive. It doesn't smell of anything. I said the scent won't come with it, and leaks are going to become much more common. I'm not sure where else it's going to get rolled out. I don't know if it has rolled out here yet or not, but I have been told it is going to happen in the next while. So with that out of the way, that explains why I've got it. Also why you should consider getting one if you live in an area where you are not connected to the national gas. So I should explain, there is a bit like the electricity grid, there is a network of backbone gas distribution where they have huge, very high pressure gas mains that run between major cities in the country. Those don't have hydrogen in them yet, as far as I'm aware. I don't think so. What they're doing is in small areas, so I live in a fairly small town which is rural, we have a gas network, but it is not connected to the national network. It is just fed from a big storage depot where they have huge gas tanks that are like the size of buildings. They bring the gas up by truck and pump it into those tanks and then regulate it down to lower pressure and distribute it from there. In systems like that, they're beginning to roll this out, I think nationally, not just in Scotland, I think nationally, but again, I'm not 100% sure. If you're in doubt, it might be worth asking your local gas distribution company what their plans are, what areas they're doing, when they're doing it, so on. Anyway, with that out of the way, let's talk about the machine itself, how it works, because that's also quite interesting. So, there are a few ways in which these kinds of meters can work. This one here, you can tell how it works based off a couple of things, both of which are in the instructions. If we look here, it specifies the batteries as 6 LR20 1.5 volt alkaline, and it specifically says alkaline as well. So 6 D-cell alkaline batteries, and I'll tell you these are all in parallel as well, means this thing draws a huge amount of current. It must do, otherwise it would not be using D-cells, it would be using something else, and probably less of them. So drawing a huge amount of current is one clue. The second clue is much more explicit. You can see here, it says, caution, silicon. Silicon vapours will poison the gas-sensing filament and give faulty readings. Do not use the IG5 where silicon compounds may be present. The IG5 should be recalibrated if it has been exposed to silicon vapour. That means that this uses a catalyst-based filament detection method. What does that mean? I will explain that now. As soon as I can find my pen here. The way this works, it's very simple. It is a box. Inside the box there are 2 bits of wire. There is one that has a platinum based catalyst on it, and the other does not have the catalyst on it. The gas comes in one side in here, and the gas comes out the other side over here. The device will measure the current flow through each of the filaments. I'm assuming with the current shunt probably. And when a combustible gas is in the air inside this chamber, it will oxidise rapidly on the platinum catalyst on the heated filament. that oxidisation reaction is basically the gas burning, but in a very controlled manner. So that will increase the temperature of the filament, and when the temperature of the filament goes up, it will change resistance to the filament, change the current flowing through it. By comparing the current flowing through the uncatalyzed filament and the current flowing through the catalyzed filament, you can use the difference to determine how much combustible gas is present in the air. This does not discriminate what combustible gas it is, so you can use basically any combustible gas. It could be propane, butane, methane, hydrogen in my case is the important one, but any gas that will go through the detector. It's worth checking if you buy one that the one you have bought is capable of detecting the gas that you're worried about, because not all of the detection modules can detect all gases. Some of them are specific to only hydrocarbons or only specific things. The reason this gives warnings about petrol vapours and hydrocarbon vapours and that kind of thing is because if you end up with either a very high concentration of gas in the chamber or something like a droplet of petrol condensing on the filament itself, it can become so hot that you basically burn the filament out, and that's the device written off there. That's the end of it. You're not going to be able to fix that unless you replace the filament. Anyway, with that out of the way, I will go over how you actually operate this device. I'll show you it working. So 1 second while I get the butane to test it. So, how to use this device? Very easy. There is only one control on it, this knob here. You lift up the little cover thing, click it on, you'll see the needle deflect the whole way across and come back. That tells you the batteries are good. You then turn this knob slowly, and you'll see the needle will jump up, and I keep turning it, the needle will go higher and higher. I want to turn that until the needle is about over the 0 mark, and like that. Then, what you need to do, I'll just move this aside so you can see. You take the bulb, cover at the end of the holes, squeeze the bulb, and it should not leak like that. There we go. It should be like that, and then when I let go of the end, it inflates, which is good. The seal on the end of this one is a little bit iffy, but it should be fine. Just give autofocus a second there. And then what I've got is I have a just disposable Bic lighter, which I'm going to use as a source of butane for it. So if I hold this next to the end, do that, get a few pumps of this, and you can see there the needle goes all the way up to off the scale. The very important thing with this is that you keep aspirating until you get it right back down to 0 again. If you leave explosive gas inside these, you will damage the elements on them. So I'm just going to keep pumping this away until I get it right down to 0. That might be as low as I'm going to get it. Yeah, I think that's as low as it's going to go. But anyway, that is how these work. The way you would normally do it is you would have the big long tube on the end of this. You shove that into your manhole, or you use the sniffing lead. You poke it around whatever you think might be going to leak gas or might have gas in it, and you just keep pumping the bulb slowly. And as you're going around, you see, and if the needle starts to deflect beyond 10%, at that point you stop and you call the gas company and have them come and deal with it. If it is a mains gas thing, if it's bottle gas, then you have to call a gas engineer to come and fix the problem. Turn it off afterwards, because if you leave them on for too long, again, you can burn the filament out. I'm not sure how long it is the maximum you're supposed to leave this one on for, but I wouldn't do it for more than, I'd say, 5 minutes, and then turn it off and give it a while to cool, to avoid damage to the element inside. Anyway, as I say, I think this is quite an interesting device. I think something that is, I would say, mandatory really if you're doing duct work, especially in an area where they're rolling out hydrogen, because it's going to leak. Thank you very much for watching. Hopefully you found it an interesting video. A bit of a departure from normal, but still, I think, somewhat relevant to the general gist of the channel. I will see you in the next one. Remember to like, subscribe, any questions, suggestions, whatever, in the comments, drop them down below. And yeah, I'll see you in the next one. Bye.